Of the billions of species that have ever existed on Earth, one stands out the most: us. Just look around. Even the smartest primates can't compete with human creativity, ingenuity. But why? Sure, you can boil it down to differences in neuron density, brain size, but these don't reveal the cognitive underpinnings of our humanness. So what are they? What makes us so uniquely us? According to Dedre Gentner of Northwestern University, it begins with a simple move the brain seems designed to make. We compare.
I didn't even discover that the kind of psychology I do existed until I went to grad school in physics.
Gentner was good at physics, but that couldn't answer the burning questions texts like Kepler's treatise on the solar system and Rutherford's descriptions of the atomic nucleus inspired in her. Gentner's passion became the nature of discovery itself. How does the human brain do it?
I happened to stroll through this building. I walked by this classroom, and that's what they were doing. Viewed from the present, it was so primitive, it was rats in mazes, but still, they were doing actual experiments on thinking.
Gentner had stumbled into the nascent cognitive psychology department. She was hooked. She left physics and became one of cognitive psychology's biggest disruptors.
Early on, cognitive scientists tended to think the brain built an understanding of the world by grouping lists of features into categories, a process rooted in memorization. Ears, eyes, claws equals predator.
And I thought that is absolutely inadequate. It's not enough to just say, cats have claws and ears and eyes. How does it all connect?
Gentner was onto something. The groups and lists model was missing an important ingredient. You can't make the leap from claws to predator without context. In fact, context seemed fundamental to the brain's learning mechanics.
Gentner realized that to contextualize, the brain must constantly be drawing on past experiences and information. She had the novel idea that the brain was always comparing, seeking relationships between ideas, building an understanding of the world through analogies.
Gentner developed the idea into a revolutionary computational model of cognition called structure mapping theory, in which the brain maps the properties of a familiar idea, flowing water, to new information like electric current, bridging the gap with analogy. Moments after we're born, the analogical construction process begins. In our first year, abstract shapes acquire meaning, unlocking new ideas. Over time, our perception of the world emerges as a web of interrelated concepts, independent yet inseparable through analogy and metaphor. We are always comparing, new ideas integrating according to structural similarity, and with enough touch points, the right number of connections, discovery happens, a new idea. The proof happens in Gentner's lab, where children under a year old begin to demonstrate our human ability to make comparisons. Non-human primates, on the other hand, our closest intellectual contenders, mostly fail analogical tests. What separates our species intellectually may just be rooted in our ability to compare.
Seeing two things together is often hugely illuminating. That's the magic of analogy.
In 1989, Gentner's model became code. She helped computer scientists introduce the structure mapping engine, a symbolic AI program that generates human-like inferences from analogies. It was a bridge between cognitive science and artificial intelligence.
That was just a revelation, and I really do think that's how people do it.
We are constantly comparing, crafting our perspectives within a proverbial hall of mirrors, in which everything reflects an aspect of something else. There are infinite analogies to draw from, infinite discoveries to be had.